Great to be here in Kiev today. My name is Oleg Andreev. I'm living in France, in Paris, but originally from St. Petersburg, Russia. So today I'm going to talk a little bit about some object-oriented programming technique, just one, which helps you greatly reduce your code, which you write to connect your server-side application with your client-side application in JavaScript. So let's start with defining the problem. The typical web application usually does four things. The first one is it receives the request, then it routes the request to the proper part of your object-oriented application, then it does something with the data, writes, reads, modifies, and finally it prepares the page to return to the client in HTML. So for every step here, we have great variety of tools and great quality of tools actually. So to receive the request, we have a lot of servers to choose from. We have Passenger, Nginx, and some cloud services. For routing the requests, we have Reg API, we have some frameworks, Rails for fat applications, Sinatra for some lightweight stuff. And talking to database, we have also a lot of libraries and databases and relational ones, or some kind of document-oriented databases. And finally, to return the HTML, we have also a number of template engines and some helpers and builders, whatever. So actually, the problem lies here in the bottom of the list, in this last part, because this thing is not object-oriented. Here you simply have some HTML code which you just emit line by line, and comparing to the other part, it simply looks like some stupid PHP. So this is the problem. So actually, why is it a problem if you just return the HTML and it works in the browser? You have to return it anyway. So the problem is that you want to leave this HTML its own life after you return it, and this is just because of the script which you run. So you have like another afterlife of the application after you just prepare and do some stuff on the server. So let's demonstrate what actually happens here. So the Rails application looks like this, and you have some page, and this page is usually containing some HTML template, and this page also has some part which has some other HTML template to be rendered in, like this. Then you have some data to render in this element, which is returned simply by printing out some field from some model object. Then you have some control, which also is rendered with some HTML template. Then you have some button, which is rendered with some helper function, and then you convert everything to HTML. So this is simply by just emitting the HTML, and the real application you get something like that, just tons of HTML stuff, and you don't really see the structure anymore. You don't see those controls, screens, data, nothing, just HTML soup. So you want to make it run actually. So you take the tool, you take some jQuery or a prototype, and you start to digging in this HTML code and trying to pick out the important parts with some jQuery requests or whatever, or some unobtrusive JavaScript to take from some data attributes. And you convert this thing into this thing, which actually is much more like object-oriented programming, because now you have something like controllers, models, some views, you have actual objects which you can speak to and to do something useful. So we're coming from Ruby, which looks like that, to JavaScript, which looks like that. And since Ruby actually is just emitting HTML, we have some glue code which transforms this HTML of the JavaScript objects. And this is the problem, because you have a lot of this code in the middle, and you have to change this code and maintain this code each time you update your application logic. And you update it like every day, and you have to maintain this stuff in the middle every time, and if you make a mistake, you will have some strange errors in the client side, not this in the server side, which is really hard to debug. So we have to solve this somehow today. So first of all, we just will get rid of this stuff, and then we will transform the Ruby things into direct mapping from Ruby objects to JavaScript objects. And this will let us avoid writing this glue code at all. We will just modify some server-side logic structure of the objects, and they will map automatically to the JavaScript part. So in part 2, we'll talk about the framework, how we will do this. So let's back to our application. And it actually consists of some objects, right? It's the model view controller application. So let's just take a look what objects do we have and how they're connected to each other. So first of all, we have some models. Here we have the playlist, which has tracks, and also each track can have an artist. Then you have some views, like the overall outer frame, which may contain some other inner views. And to make them work together, you use some controllers. So here we will have 2 controllers for the whole player and for the single track. And these objects, just like created here, they're not connected to each other, so we'll show how they're connected. So first of all, the models, they form some kind of hierarchy here. Like the playlist has tracks, and tracks has an artist. The views are also like a tree. And controllers also own each one the inner controllers. And now controllers also should know about models, so they can talk to them and take some data out or write out something. So the playlist controller will have a playlist, and track controller will have a track. Then controllers will also have to talk to the views to update the views. So some controllers will have some links to other views. And also views can have some link to the controller. For instance, the button can have a link to some controller to send an action, like I was clicked or I was double-clicked. And also view can have a link to the model. For instance, the display can just have a track to take some data from it to display it, which is simpler than just passing some strings in. So we have this thing. And what we have to do is to just create this on the server and simply copy to the client in the JavaScript. And this is what we have to do. So how are we going to do this? So we may start with some root object, some kind of page controller, like the most important object we have to start with, and create some kind of JavaScript representation of it. For instance, by dumping it to JSON. Then we will dump this into the JavaScript part of the page and assign to some JavaScript variable. And then we will just wrap around the web page. So the JavaScript will just take this metadata from the JavaScript without digging into HTML. But this actually doesn't work. And the reason it doesn't work because this is not a tree. This is what we have is a directed graph. It's not a tree, and the JSON is designed to dump the trees. And directed graph has 2 very significant differences from the tree, which are, first of all, the multiple references. Each object can be referenced multiple times. And if you just dump to the JSON the structure, you will have 3 copies of the same object, which probably is not something you want to have in your JavaScript application. And second, you have cyclic references. Each object may have some references. This is a simple example. We have a much more deeper chain. And this will cause some infinite loops if you try to just simply dump it in a tree-like structure. So let's solve it with thinking about what the graph is. So it actually is 2 things, not the one. And the one thing is this is the collection of objects you have. And the second thing is the collection of references between them. So this is almost like the definition of the graph in the formal one. And we will use this definition to try to write some actual code to fix the problem. So we will just take those 2 lines, the objects and the references, and do the following. In the code, we will first create the objects and then connect them. So you have those separate operations. So how are you going to create them? This is going to be simple. You will have just a local variable, which you instantiate in some scope, and you use the class in JavaScript for the prototype, or you can use some other method to instantiate the class depending on what framework you use for your object-oriented programming in JavaScript. And you just create it without any arguments and without any attributes, just an empty object. Then you do the same thing for another object in your graph and for another object. And for instance, for the views, you can not create something from your class. You can simply take the object from the DOM, from the HTML document tree, if you want to, if you need some simple view, or you can create your own class for some more complex view. So it really doesn't matter here. What matters is that we just simply create empty objects, and the order in which we do this doesn't matter. So second, after we've done this, we have to connect them together. So this is simple. You just have an object and a property, and you assign another object through this property, which is very simple here because the word on the right is the same as the name of the property usually. Like you have a display, you assign it to display property of some object which wants a display. And same thing for every other object, which is quite simple here. And still the order is not important because we just instantiate some private data in the objects, and we don't care in which order it happens because they don't talk to each other yet. And this leads us to the question: how we're going to initialize them? How at what point we can make them able to talk to each other? So the constructor we used doesn't take any arguments, so the object is just empty. So we have to initialize after all the objects connected. So for this, why we're going to need this? Because we want to, for instance, assign some on-click handlers for buttons. We just connect to the button, but then we want at some point to assign some on-click handlers, or we want to display some default information in the views. So for this, we will use the awake method, which is not like an initialization method because the objects are partly initialized, but we will have the opportunity to tell them, like, now you're awakened, you was asleep, but now you're awakened and you can actually talk to some of your fellows. And this will look very simple. We just take every object and call the awake method on everyone. We can actually wrap it like, if object doesn't respond to awake, we just don't call this method, but the principle is the same. And still the order is not important here. And the order, you simply cannot impose any order here because the graph doesn't have an order, it's not a tree. We don't know in which order the objects were created initially in Ruby, so we cannot know in which order to do those iterations. So when you write your awake method implementation, you should know that you should just awake some private stuff in your object without depending on the awakeness status of every other object. And still we want to have some point in time when we just synchronize the whole graph, when we know that like the whole thing was awakened and now we can run some timers, like play some game, whatever. So for this we can just have some method on a root object which we start with, which will be called with something like did-awake call. At this point we will know like only one object receives this message, and it is capable to like initialize the whole system and start doing some things. So let's look at what code do we have here. This looks like this. We first create objects, then we connect them, and then we wake them. And for easy to use, for flexibility, we just wrap this in a function, which will return the root object. So whenever we call this function, we will get a root object, which is connected to the whole graph, which is super cool because, like at this point, we call this function, assign to the root variable, some window.pageControl or whatever, and then you can wrap it into some DOM-loaded handler when you know that the whole document is loaded, and then you just wrap the script in the bottom of the page, and now suddenly you have everything. So now the page loads, the window.controller has the stuff, all the wake methods are called and connected to the event handlers, and now you have the live code. So the only thing is how we generate this function. So we simply have some Ruby code to generate this function, and it will look something like that. So we have some root objects in Ruby, and we encode it into the graph, which we present as a JavaScript function, and we inject in the HTML page, and then the browser does the rest of the things. It just runs the JavaScript code, and everything's live. So the last part is what is the algorithm for encoding this graph? So in a nutshell, it consists of these steps. First, you have two tables, just like in the graph definition. You have some table for objects and some table for references. Then you take some root object you start with, and you add to the objects table. And then you ask this object, what references do you have, or what references do you want to encode for this particular work, for this interface? And the object tells us the list of pairs, of key value pairs, of the references to other objects with names. So we will take all those references, and for every object continue recursively the algorithm, but skipping the objects already added to the table, so we don't loop infinitely. And when it is done, we have those two tables for objects and references, and we simply translate them to any language you want, to JavaScript, or to JavaScript with jQuery framework, or to JavaScript with Prototype framework, or Perl script, it doesn't matter. We just have those virtual tables to create the graph, just as it was shown before. And just to make this work, we have to design some kind of API, because the algorithm in pure form is not very usable. So for the API, we will take the inspiration in the 1988 when the French guy, Jean-Marie Hulot, which worked in Next Step company, which became Apple. Well, it was bought by Apple, but actually it was Apple, because most of the technologies were just taken from Next Step, which we use today. And he created the interface builder, the first program in the history of computing, which allowed you to visually create user interfaces by just moving the mouse on the screen and connecting some control points. So this is a picture of Jean-Marie back in the 80s. His Next Step computer. This is the first, or almost the first screenshot of the interface builder back then, and this is how it looks today. Actually, is used as a part of Xcode system, which is used for Mac applications and iPhone applications development. So what does it do? So first, very simple, it allows you to lay out the objects in some file, like for a window or some for iPhone screen. You just put the sizes, colors, whatever. But more than that, you can put in the controllers. So what are you going to do to even want to put the controllers in the interface file? So the reason is simple. You can connect now the visual objects to those controllers to make the controllers respond to some actions. So you can say this button will send some click event to this controller to this method. And then what you have to do is to just write a little bit of code in your controller class which responds to this method. And you don't have to create the controller, you don't have to think when to create the controller and how to connect to this button. It's absolutely automatically done in the NIP file, in the interface builder file. And the reason for that is that you actually can put any object there. Whatever, the models use controllers, you can put the trees of objects, which contain some other objects, and connect them whatever you like. So this is the example of the UI of the interface builder, where we have the window, the table, the button, and we have some even application objects in the file. You see it in the third line here. It's the whole application object which works with the operation system is created in the file. And you have some array controller to connect the button to array controller to add some new entry in the conference participants list. And this is very cool because actually what it does is it has the freeze-dried graph objects in the interface builder file. So it's not just user interface, it's just the whole graph of objects. And this is exactly what we're trying to build with Ruby and JavaScript. We could try to build this graph in Ruby, transfer it to JavaScript, and awake it and make it work. So we were talking about the API, how we find out what the API we should use. So let's just go to apple.com, to the developer section, and see some guidelines and documents which describe how it works. And I really suggest you looking at the Archives and Serialization Programming Guide, which talks thoroughly about how it works, how graph is built, and what classes and methods you use. And also it has the docs on NS coding protocol, which defines how objects participate in the graph creation process. And some custom coders which actually implement the building of the graph. An S-coder is a base class, and you have some cheat archiver or unarchiver to encode or decode the objects. So let's look at the NS coding protocol applied to some of our applications-based controller. So we have the method. This is in Objective-C. It's called encode with coder, and the coder is a parameter which is an object which creates the graph and contains the graph in itself. So it's basically like a callback from the coder. So coder goes through the graph and calls this method, telling the object, like, tell me how to encode yourself so I will keep you in the graph. And this is what it contains. First, you just tell the coder that I contain the object, the playlist, with the name playlist. So you know what object do I reference and how this reference is called. And I do the same thing for every reference I have. This is very simple. So we have the tracks, we have some other controllers with models, views, whatever object I want. And I can actually tweak with, play with some names here, but usually you keep it simple. You have the local variable name, the same as the reference name, the property name. And you just do nothing, don't return anything, just tell the coder that this is my references. And in Ruby it will look very similar. You just change the syntax, basics are the same. So where does it lead us? in Ruby we will have an object which is called JSCoder, which will be a coder which is able to create the JavaScript, and we will create this object. We will tell this coder what the object to start building the graph with, and we will tell it, like, please encode the stuff into your internal state. And somewhere in JavaScript we will tell this object, after it has encoded the graph, please give me the JavaScript representation of the graph. And for the algorithm which is used in the JSCoder, it was described, but at the actual code you can take a look at it on the GitHub on my page. It is just a single file called RB, and you can find some example in the bottom of the script. So if you just launch it, it will return you JavaScript into the terminal. And inside the file you can see what actual the structure of objects is defined in the Ruby part. So you can just take a look right now if you want. And so what does it mean for the developers? When we've done all this stuff, how the work will look like right now? So we have some Ruby objects. We call this magical JSCoder. We create this graph in JavaScript. What are we going to do next? So I will remind you that the Ruby object was transparently translated to the JavaScript object, and so for the Ruby classes. So we just take the Ruby class and assume that we have the same kind of JavaScript prototype with the same name as JavaScript. So what we will have to do is to just simply create a file with some class with the same name as the class in Ruby, and fill in some blanks like await method and some other methods we would like to have. So this is like our outline, what we start with. And inside the await method, we will assume that we already have the button connected to the subject, and we will tell this button to bind some event listener. And this event listener will be our method in the same controller object. And this onClick listener will have to assume to have the track and the display objects, which are connected by the graph automatically. And we will just do something with them, like toggle the play pause state or update the display with some new data, whatever. So why this is really cool. So first of all, you don't have to connect those properties second time in JavaScript. You have created this in Ruby, and this is automatically done in JavaScript. Don't think about it. Second, you don't have any dependencies on any global state. In this code, you don't participate in any kind of tree of responsibilities. You just have your class, you have your connections, and you don't care of the rest of the world. And also, you don't think about the time, at what order the things were initialized. You don't keep this in your head. It's done automatically. And finally, what it leads us to is to have the piece of code which is highly recyclable, so you can move it around, rename, breaking the pieces without thinking about breaking some other code. So this solves a lot of problems. And this is what you finally will get if you use this kind of technique. So, and then the final part of the talk, I will just show you what actually you can do further, not just simplifying your code, but taking this technique and doing something more interesting than what we do today. So the next thing is that you have to somehow find the framework for the object-oriented use in Rails. This talk doesn't cover this. It assumes that you have some kind of implementation, and I have to come up with some kind of implementation, which I'm not happy with it entirely, so don't open source it. But it worked well for one of the projects, but it's like not the ready framework for use. So you have to, you as a community, we have to find out some way to have some object-oriented views in Rails. Right now, they are not object-oriented entirely. Next, once we've done this, and once we use this kind of technique, we can make the what you see and what you get technique to be very ubiquitous. You can make it very simple to have some inline editing controls everywhere for making users more happy and more productive. And finally, you can do something crazy, like even building your website or modifying your structure right from the web browser window, once you have the technique to just map the objects from JavaScript to Ruby or from Ruby to JavaScript, which could be really cool and looking really like in the 70s, the Smalltalk system, where you have the live system with objects and you edit everything in the real time. You can make, you may use this technique to make something like that in Ruby and JavaScript. So this thing was invented when we had a problem with our customer Les Echos. This is a French newspaper. or a French media company. And the website contained two very hard pieces. First, it was the form for registration for the subscription. And this was a very complex form. It contained some variable number of blocks with some subforms. It contained some logical connections between some controls on the top to some appearance in the objects on the bottom. Also a lot of logic about some countries where we have different taxation rules, etc. So what we came up with is to design and build the whole thing in Ruby, translate it to HTML, use the JS coder to create this JavaScript representation, and create the appropriate JavaScript classes to handle some logic from the client side. So this saved us a lot of code from taking some stuff with jQuery from the HTML. And second, it was the editor of the product pages in the same website, where the administrator could open the product and edit the appearance on the page of this product, like create some new blocks, upload pictures, change the text, rearrange some stuff. So also it was built on the graph builder like JS coder. So this is it. Thank you very much, and I'm glad to answer all your questions if you have some, and to show you maybe how to use this product. Thank you.
Shiglov Andrei. Shiglov Andrei, do you have some code that shows some full example of usage?
Sure, you can download the open source file from GitHub. It's just a single file. It contains the algorithm and also example code. It's not very simple. It's not very complex, so it's easy to look. It just fits on the screen, which contains the models using controllers. It's just like the sample application. And it shows how to encode this stuff in the JavaScript. So you just download, run, and see. It's just in a single file.
Okay, thanks.
Hi, Mike Lewarsky. Do you have any solutions for test-driven development in that way?
What actually would you like to test? You can test your application logic when you build it?
Yeah, the logic.
Sorry?
Yeah, the logic.
No, it's. I mean, there is no like special framework for testing. You just have your stuff built in the JavaScript. Then you can put some additional page which just looks that you actually have what you want to. I have the unit test for the coder, so I make sure that I encode all the types and objects properly, even some very edge cases. So you can like actually trust the coder itself. So you can trust that it creates properly the graph. But if you want to test your application logic, it's really up to you.
So it's impossible to create tests for created logic?
It's just another task. It's not the task of the coder. It's the task of application writer, or the one who builds some stuff on the client. It's not covered with this library. It's not even a library. It's just a single object coder.
Okay, thank you.
Andrei Shiglov again. So, if this code doesn't work without JavaScript at all, as I assume, why don't we need all those Ruby transporting objects? Why don't we use just JavaScript and Ruby gives JSON with data?
You're probably talking about something like Gmail, and you have some simple server which can just send some pure data to the client, and the client does all the work with Ajax, JavaScript, etc.
Yes, exactly.
This is a thing for another kind of problem when you cannot afford building the Gmail. Sometimes you just cannot do this thing. Sometimes you build the application entirely in JavaScript and you have some REST protocol to talk to the data server. Perfectly, it's not the solution for that problem. This is a solution for the problem when you cannot afford this. You have to have normal HTML pages indexable by Google, which should work like without JavaScript, and you simply, sometimes you don't even want to build some crazy, very complex UI. Sometimes you only have to have some logics here and there and somewhere here, so you just don't want to pollute your code with a lot of jQuery to talk to this stuff. So this coder allows you to build your HTML page and just to replace your jQuery mess with just creating your classes, some placeholders for the classes in JavaScript. It's not about building the entire application in JavaScript. Okay. Well, if in the future we will have every application only looking like Gmail, then it will be obsolete, of course, but for now it's not the case.
Okay, thanks.
Sergey Kish, just I want to make it more clear, and as I understand, it's very similar, for example, for creating entire site, server side on JavaScript, and importing some of the code to client side, right? So, for example, we have some application that works using HTTP, a lot of pages, etc., and we can create that all the stuff on one page using Ajax, right?
We can't or we can?
Can. And that coder is a bridge between Ruby and JavaScript both.
Sure. And actually you can use it not only for the static HTML page, you can use the same idea for communicating with JavaScript. You can ask for some partial in JavaScript or for some data and use the same technique to get some stuff and inject in your running page. It's not tied to the static HTML. You can use it with Ajax as well.
And can you give some more examples of using that technique?
Another example probably will be, well, all the examples should be running in production systems, because in theory you don't need all of this, because in theory you use Haskell and Monads to solve all the problems. But in real life you have to take some real coding to solve some real stuff. So the example was the Lisico, and for instance you can go to Photopea website. Photopea guys, they copied my library when I just started to doing this, and they did some modifications, but the idea is the same. They have this rich website for photo sharing, and they have a lot of dynamic controls to work with. They still have those HTML pages. It's not entirely JavaScript application, but they want to power it with some nice JavaScript actions. Sometimes they are really important, sometimes they are just additional things. And just to simplify the code, they use the coder to just clean up the mess. This is the example.
I'll take a look.
Okay. It's photopedia.com with F.
Hi, my name is Adam Horetsky. I wanted to ask you that about the framework that you built, that the parts in JavaScript that you showed, that's really a dependency injection pattern, right?
You may call it so, yeah.
Yeah, so you basically are building a graph of objects based on some sort of configuration. And my question is, why did you choose to make the configuration in Ruby and have all the JavaScript classes mapped to Ruby classes, have the same names and stuff, instead of just having the JavaScript dependency injection framework?
Simply because it doesn't solve the issue I was talking in the first slides, because you still have to take some data from the server. Of course, it's not an issue if you have a very plain server, but if you have to generate actual HTML, some rich HTML, and you have to make it work like without JavaScript, or with some kind of flexibility about it, like you can disable this JavaScript if your requirements change. And once you build this HTML, you have to take the data somehow from somewhere, and before you pass it into some kind of dependency injection framework, you still have to write this glue code and to maintain it.
But you still have that glue code. You just call it Ruby classes and specify some properties on them that say...
It's very different. It's very different because in Ruby you have your logic expressed in simple objects relations between objects. Just as you have relations between models or controllers, it's inherently the part of your business logic. It's not some kind of glue code. So the idea is to just take your logic and probably enforce you to put more of your code from stupid ERB files, from stupid templates, into some object-oriented stuff to like have a button as an object, connect to some view and connect the view to a controller, just to make it clean, right? And this will be your business logic. And then you just call the magic function and it creates your JavaScript code. So the glue code actually is automated inside the coder.
Oh, okay, but you still, there's a difference between, say dependencies, so model, controller, stuff like that, and their properties that are simple objects like strings and dates and stuff.
Sure, we're talking about properties which contain not only strings or some scalar symbol values, but links to other objects or arrays of objects or hashes of objects.
So you basically still have to specify what is the simple object that's serializable and is a value object, say, and what is component or something.
Yeah, I was talking about the encode with coder method. So, like, basically you have to provide for each object this kind of method which tells what properties do I want to encode. But on top of this, I have some nice levels of DSL which help you to simplify the things. Like, you can just have a single call to some method inside the class and tell it, I have this track playlist and track controller property serializable, like codable to the graph. So you have this one line of code for your object and it's done. If you want to go further and encode all the attribute accessors, you can write a little bit of DSL and say that, okay, I just want to do everything automatically. I don't care about the slight differences. Just encode everything. If you want to do this, it's very doable in this library. So the only configuration is just to tell to every class what properties it wants to encode. And this is usually one line of work, and lets you control what you actually get in JavaScript. This is all. I probably should show you some sample. Right now it's easier just to download the file and you will see in the sample how it looks like. It's just a single line with the list of attributes which are codable.
Okay, thanks.
This is the configuration, yes.
Any question? Okay. So we thank you. And,
Thank you.